So, student, now in this lecture, I'll start basically concept of heat and temperature. So, basically, student, what is the point which I'll discuss in today lecture, right, my dear? So that is just before going to start any of the topic. Just I wanted to give you what is the layout of today class, right, my dear? The matter is defined as any substances that has mass and occupy space, right? So, temperature is one of the physical properties of matter. What is it? This is the key point. Temperature is one of the physical properties of matter. The temperature of matter defines the state of it. What is it? Temperature at hello Vidya Vita, how are you, my dear? Yes, it's good. Let me continue. The temperature of the matter defines the state of it. Also, there are other temperature-related properties of matter like you can take with a thermal conductivity, thermal diffusivity, and so on. Right. So, student, okay, Dida beta, what about your health beta? How are you now? Is it fine, beta ji? Oh, you wrote. Okay, very good. Very good, my dear. So, student, in today lecture, okay, very good, beta. I'm very happy to, beta, heard about your health, right? So now, student, the temperature, as I said, the temperature of the matter defines the state of it. So temperature related to what properties of matter like thermal, as I said, thermal conductivity beta and thermal diffusivity and so on. So in this chapter, student, what I'll discuss more, what we are going to learn, we will learn about temperature, heat. What is student? In this chapter, what I'll discuss, student, we will learn. Peter, God bless you for reaction, my dear. Sir, will you check each chapter? Yes, yes, Sagar beta. Yes, beta. Today, Sagar beta, I'll beta complete your syllabus. Today, Sagar beta, this lecture beta, I'll try to complete your theory point all. And beta, tomorrow beta, tomorrow, I can say the timing which 7 to 9 or 7 to 10. Beta, I'll complete entire bacha party, I can say numerical section based on today class. Divya wrote something. Yes, sir, I have completed the lecture too. Very good. I'm very happy to see Divya Beta ji. Very happy to see the chat. So, student, in this chapter, beta, we will learn about, my dear, we will learn about, my dear, temperature. Student, we will learn about, student, that is temperature, heat, temperature, heat, student, thermometry, student, thermometry. Next, beta, thermal expansion of solid. Student, thermal, thermal expansion of solids. Thermal expansion of solids, or you can say, beta, thermal expansion of matter. Right. And last point, beta ji, that is, my dear, calorimetry. What, my dear? This is what? Hello, Sagar Beta. Calorimetry. So, Sagar Bacha, this is the point which I'll discuss over here. In today's class, we will learn about temperature, heat, thermometry, thermal expansion of matter, and calorimetry. Right, my dear? Okay. So, students, now onwards, I can say just I'll discuss basic point about heat. Student, I wanted to discuss about, my dear, basis point about heat. Then I'll start with the chapters as usual. Right. So what is the heat? Student, I'm writing a meanwhile because students, less students joined till now. Vitaji, heat is a form of energy. My dear, heat is a form of Vitaji, heat is a form of energy which produces the sensation, the sensation of hotness. What was it? The sensation of hotness. Okay. Beta, just what is the heat transfer? Beta, these two are very similar, my dear. These two are very similar, my dear. You can tell which heat flows from what which is the higher temperatures to lower temperature of body. What student you can write heat flows from student higher temperature of bodies to beta lower temperature of bodies. Beta, this is also a quintile here. That is what heat transfer. Student, you can also say heat transfer. What is the cause of heat transfer? Who is the culprit for beta the heat transfer? Heat always flow from what? Let us suppose, student, you can understand like this. This is the container. In this container, students, I'm considering there is a water filled. Temperature of water, beta, let us suppose I'm considering here 80 degrees Celsius. So this is what, my dear, you can say container A. Now, beta, now this is the beta. I can say this container A, beta, due to some, you can use some sources. And student, you have to just connect beta Z to body B. This is body A, my dear. This is body B. And you can take in consideration beta. This body has a temperature beta Z 39 degrees Celsius. What beta Z? 39 degrees Celsius. Right. So beta Z, what is the beta temperature difference from here to beta here? So heat transfer beta what? You can say body A to body B. What which is the body A to body B. This is what, my dear, basically heat transfer. Okay, now which are just we'll discuss a basic point about heat. Remaining point. This is what beta. Heat is the what thermal energy of body. What is student? This you can keep in the mind. Heat is a beta. This is thermal energy. This is what, my dear? Thermal energy of body. Saga tell us heat belongs to quantity. The beta heat belongs to quantity. Initially joined many members, but now very less number is present. Tell beta heat belongs to quantity. Sagar Divya, heat belongs to quantity. Heat belongs to quantity. Sir, should be copy notes. Yes, yes, beta. Yes, NS beta. Yes, NS beta. Scalar. Yes. NS beta, respond me beta. Answer also बच्चा. Yes, beta. So beta. Good, yeah. Good, Sagar beta. Your answer correct बच्चा. NS also. Oh, very good. NS, very good beta. My dear, very good बच्चा. Okay, so beta, what you can say? Beta, heat belongs to what beta? Quantity. It belongs to quantity beta. It, which has it belongs to quantity. That is what made is scalar. That is what made is scalar. Okay. Now tell me, sir, what is the SI unit of heat, my dear? What is the beta G SI unit of heat? Bacha Ji, what is the SI unit of heat? SI unit of heat. Hello, quickly, bacha. Don't waste too much time. SI unit of heat? Sagar Maharaj, what is the definition of heat? Where are you, my dear? You joined lecture on time only. No, NS beta, wrong answer. What is heat? Listen beta carefully. Everything because you know why I'm writing NS beta so that you can easily understand class beta G. Heat is what? A form of energy. Heat is what, Bachar form of energy. Oh, why Sagar? Why Sagar? Why Sagar, beta? Huh? Okay, heat is what, beta? The form of energy, right, my dear? So, heat, what is the, till which NS? What is the SI unit? Okay, good, got it. What is the, beta G, SI unit of heat? Tell me, what is the SI unit of heat, my dear? Tell me fast. Joule, correct. Now your answer correct. Your answer correct, beta. I can say NS also and Sagar beta, both of you, bacha. So here you can write bacha party SI unit of heat. That is what beta? Joule. That is what bacha party? Joule. Okay, now bacha, I wanted to discuss beta the more basics point here. Beta ji, I wanted to discuss bacha more basics point, right? So bacha ji, next point, student, I wanted to discuss that is nothing but beta. It's a pressure. This is what, my dear? Pressure. What's the pressure here? Just tell me now. Just finish in fluid beta. Just now beta we finish in fluid here. Pressure definition bacha party. Tell beta. Okay. This is what beta. Just now we finished here. Pressure is what? That is just now we finish here. Pressure is what? Tell me. Pressure is equals to this is force. Good beta. F perpendicular beta Sagar Maharaj beta. F perpendicular upon area. Pressure is what? F perpendicular beta what? Upon area. Okay. Now tell Bacha ji. Pressure belongs to quantity. Tell beta ji. Pressure belongs to quantity. Tell beta ji. Pressure belongs to quantity. Pressure belongs to quantity. This is what beta? Scalar. Okay. Next point beta about pressure. What is the SI unit of pressure? Tell me quickly. Correct, correct, correct. Correct beta NS. And now beta tell me here. What is the SI unit of pressure? Tell beta buddy. This is what you can write Newton. Correct, 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 Sagar Maharaj beta. Correct, Sagar Maharaj beta. We are always under atmospheric pressure. It as if we are always under the what? Atmospheric pressure, beta. So what is the atmospheric pressure here? Pascal. Correct, Anis beta ji. Correct, beta ji. So this is what, my dear? You can say 1 atm, which is equals to beta 1.01 10 to the power 5 Pascal. Beta, what we can say 10 to the power 5 Pascal, beta. Beta takes natural beta party. I wanted to turn the page. Student, I wanted to turn the page. Okay, now bachas, next year. Next beta factor, students, I wanted to discuss my dear. That is what? Volume. That is what, my dear? Volume. So what's the volume here? A volume is simply defined as the what amount of space occupied by any three-dimensional solid. That is what, that is what you can say volume. I hope all of you remember. But what is the SI unit of volume? अच्छा जी, tell me here. SI unit of बच्चा जी volume. Okay, correct beta. Correct beta. Correct Sagar Maharaj. Good. But I can say NS is Rockets are for till now. NS and I can Sagar, both of you eligible for tomorrow chocolate. Right, beta ji. Okay. Now beta, three solid. Three. These solids can be A what? I can say cube, cuboid, cone, a cylinder, or a sphere. Right, bacha? 3D body. I'm just calling bacha. Okay. Yes. 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 Tomorrow I'll give you the NS because you are joining first time live session here. Now, bacha, I can say next beta. Just move ahead, my dear. This is density. This is what, my dear? Density. Right. Okay. NS beta. NS beta. Can you follow ISR? NS beta. Can you follow beta ISR, bacha? Density beta. Tell me what is density, bacha, party? What is the density formula, bacha? Rho is what? You can say. Oh, good, 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 Sagar Maharaj. This is mass per unit volume. Okay. Still, bacha, party. What is the SI unit, bacha? What is the beta G SI unit of beta G density? This is kilogram per meter cube. Kilogram per meter cube. Till beta G. What is the density of water in SI vector? 1000 kilogram per meter cube. Density of water beta in CGS here. Till beta party quickly here. This is 1 gram per centimeter cube. Okay. Correct, 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 correct. Very Sagar beta, I'm getting more reply. And yes, beta, we maintain. We maintain bacha party. Okay. Now bacha, tell bacha, what is the beta density of ice? Beta in SI bacha. This is 900 kilogram per meter cube beta. Density of ice beta in CGS here. This is beta how much here? Beta in CGS here? Tell me Sagar Maharaj. Zero point 0.9 na beta. 0.9 gram per cc. Correct, 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 Bacha ji. Okay. Now, beta, have a look next question, beta ji. Bacha ji, have a look next question here. Next concept, beta ji. So this is what, my dear. This is what, my dear. Relative density. This is what, my dear. Relative density or student. This is specific gravity. Just now, beta, we finish everything here. But you know, beta, we use beta these all concept here also. So tell Vacha party. What's answer Vacha party? Both of you answer fast Vacha. This is a ratio of my dear density, density of substance. Oh, good, 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 Sagar Maharaj. Density of beta, we can say substance upon which as we. This is what density of water. Density of correct, 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 correct. Very good, beta. NS. Okay, fine, bacha, bati. Now, beta, I wanted to discuss here. I can say about temperature. Student, I wanted to discuss about my dear. This is what I can say temperature. This is what my dear. This is what temperature. So, beta, what's the temperature? It implies energy per molecule of the body. What student first slide in right? It implies it implies energy. It implies energy per molecule of the body. It implies with what? Energy per molecule of the body. Now, the temperature is basically next with a definition. Beta just note down with me, bacha. Temperature, what was the party? Temperature is basically what bacha? Temperature is basically degree of hotness or coldness of body. Degree of hotness or coldness of body. Yes, beta. This is what the temperature is what basically degree of hotness or coldness of the body. Temperature of the body is the measure. So next one, you know what's body, keeping only. Yes, beta. Next line what's body? The temperature of a body, the beta is the temperature of a body is the the measure of average kinetic energy, measure of average kinetic energy of the molecules of a body of the molecules of the body. Next, what is the kinetic energy of molecule of a body increases. Student, no, if you are running here, you can better understand what it's very basic. If the unit is bacha ji, if you are running anywhere, right? Then beta what you can say, sir, I can say thermal energy what of the body got increased. What was the thermal energy of body got increased? So beta kinetic energy of the molecule, kinetic energy of the kinetic energy of molecules of body increases of a body, my dear. This is what increases the the temperature, the temperature of the body increases. Temperature of the body is what it increases. Kinetic energy of molecules of a body increases. The temperature of body increases. Right, bacha? Okay, last bacha ji. You can say if temperature is more, students, you can say if temperature temperature is more, then you can say bacha energy also more. You can say bacha energy also more. Bacha, you can see what energy also more. Now, beta, I wanted to start a topic of the class, right? So beta, you can say beta temperature bacha. Temperature belongs to quantity. Tell bacha ji. Temperature student belongs to quantity. Bacha ji, temperature belongs to quantity. Tell fast beta. Temperature belongs to quantity. Okay, correct. Correct, my dear. Correct, my dear. That's what is clear. But I can also say student temperature determines the directions of flow of heat between two bodies in thermal contact with each other until both acquire the same temperature. Now, beta, I wanted to discuss here one basis one related to temperature. Student, this is nothing but you can say, my dear, thermal equilibrium. What student? This is thermal equilibrium. Okay, now so what's the thermal equilibrium? Bacha? Thermal equilibrium is a situation, student, student, thermal equilibrium, thermal equilibrium is a situation in which two objects, what is student? In which two objects would would not exchange would not exchange heat or beta I can say electromagnetic radiation. What student? Electromagnetic radiation, right, beta? Okay. If they were placed in thermal, what beta? If they placed in what? If beta here you can continue. If they placed in what, my dear? Thermal contact. If they placed in what, my dear? Thermal contact. Student takes snapshot here. I hope this is it. Student this okay, sir. How is electromagnetic radiation is related to heat? Okay, bacha, you can see bacha, just we can talk about radiation. Student, you can talk about what radiation, right? Bacha. So radiation is no. This is kind of a heat transfer process. Now, bacha, you can say what kind of what heat transfer process, bacha. Beta more I'll discuss bacha about this phenomena in beta heat transfer, my dear NS. My dear NS beta, I'll discuss beta more. Beta, I can say in the chapter of what, my dear? I can say heat transfer. I hope NS got my concern. NS got my concern. Okay. I hope beta you have taken your SS. Okay, fine. Now let's see. Beta, next. Ah, yes, beta. For this condition here, beta, now I'm going to start with a thermometry. What, my dear? Next topic, beta. I'm going to start. This is thermometry. Thermo, thermometry. Right. So you can ask, sir, what is thermometry? What is thermometry? So beta, what measurement of temperature is known as beta thermometry. Student, measurement, measurement of temperature, student, is known as is known as thermometry. Is known as beta thermometry, right? Okay, fine. So basically, beta here I wanted to discuss beta many points about thermometry. But here I wanted to discuss beta in detail here. I can say what thermometry, beta, right? So what I say thermometry, measurement of temperature is what beta party known as beta. You can say beta thermometry, right? Now beta I'm going to discuss that is what scales, or you can say it's a different scale of temperature. Student, you can understand like this. This is what, my dear, different different scale of temperature. What, my dear, different scale of temperature. Okay, so basically, beta, there are kinds of scale here which I'll discuss here, and which is mentioned in our syllabus. Basically, beta, I can say we have a five, you can say, beta, kinds of temperature measuring scale. What, how many? We have a five kinds of temperature measuring scale. So now, students, I'm writing here one by one. Then, beta, I'll discuss, beta. I can say these all points. So this is what, my dear, first point. This is beta, you can say degree Celsius. Degree beta degree Celsius scale, right? Beta, second one, this is what, my dear? Degree Fahrenheit. Degree beta, degree Fahrenheit. This is which is the Fahrenheit. Third beta is the Kelvin scale. This is what, my dear? Kelvin scale. And with a fourth one, this is Riemann and with a Rankine. This is which is the Riemann scale. And last, which is the this is what? Rankine. What was that? Rankine scale. Right. These are. But with a maximum time, student, we will use Celsius scale with a Fahrenheit. Next beta is Kelvin. Beta, these two beta I'll discuss later because the students J asked beta Z. J is already asked this question lecture, right? So beta due to this lecture Z, I'll discuss little about this. But majorly beta I'll more focus I can say degree Celsius, degree Fahrenheit, and beta what I can say Kelvin scale. Okay, let us suppose beta I wanted to draw yeah, this entire Kelvin scale I can say on a piece of beta like this here. Maybe not possible. Okay, here I'll try to make. Okay, so it's I know to measuring temperature, which my dear, to measuring temperature, there are 2 points. It are to measure temperature, beta, there are what? Two standard point. To measure temperature, which there are what? You can say to standard, to standard point. What was the party? There are what? You can see, my dear, two standard point. So what's the standard point with the body? You can think like that, student. This is lower point. This is what, my dear? Lower point. And this is which is a upper point. Okay. Because lower point, what we are calling here, this is basically freezing point. Beta, what you can say with about it? This is which is a we can say beta freezing point. Lower point beta, we can say freezing point, my dear. And upper point beta, what you can say? This is what, my dear, boiling point. Beta, what you can say? This is a beta the two standard point to measure temperature of any body. Freezing point and what also I can say? Boiling point. Now beta, I'm going to discuss here in detail. Student, you can take snapshot. Right. So student, I'll make a diagram. I'll make a temperature making scale diagram beta together for all. So student, try to understand here, everyone. 1, 2, 3, 4, 5. Beta, same, you can also take over here. 1, 2, 3, 4, 5. Beta, this lower point beta, you can see freezing point everywhere. Student, this is freezing point all, and this is students, we can say this is a boiling point. Okay, beta, I wanted to just categorize it. Celsius, Fahrenheit, Kelvin, Riemann, and beta what you can say Rankine. So beta, this is first one beta. This is degree Celsius. This is what beta? Degree Celsius. This is my dear degree Fahrenheit. Degree beta is Fahrenheit. Yes, beta. Next which what is? This is Kelvin scale. K-E-L. Kelvin scale beta. Next, Riemann. This is what, my dear? Riemann scale. And next student, this is what? Which is last one? Rankine. R-A-N-K-I-N-E. Rankine beta. Okay. Now beta I'm going to write here temperature of this all. Uh, okay, yes. Beta, it is visible now beta. Everything is fine. Audio video, my dear, from my side. Yes, yes. Lower freezing point. Good night, Sagar beta. Proud on you, beta. Lower freezing point. Lower freezing point. This is not freezing point. You can say upper. You can say boiling point. Right, beta. Okay. So here, beta, you can see what's the beta freezing point for degrees Celsius scale. This is my dear 0 degrees Celsius. And boiling point here, this is 100 degrees Celsius. Beta for Fahrenheit, beta, what's the freezing point? This is beta G 32 degree. Correct. And it's beta. This is 32 degree Fahrenheit. Beta G boiling point. This is my dear 2 212 degree Fahrenheit. Yes. Very good, Anasvetaji. Okay, very good. Now, bacha, Kelvin scale here. So, Kelvin, bacha, what you can say? This is beta freezing point 273.15 Kelvin, bacha, and this is 373.15 Kelvin, beta. Boiling point. This is the freezing point. Beta, this one here, I can say for humor, bacha. This is 0R. This is what tumor beta. I can say R is what representation of tumor scale. This is what my D 0R. Now, students, I can say this is what beta is 80R. This is what my dear 80R. Right? Okay. Correct. NS beta. Correct NS beta. Okay. Next beta, which is last one. Beta, this is what 470 degree beta. This is remains R beta. Representation of Rankine. And this is what my dear 672 672 degree beta is Rankine. Yes, beta. This is what my dear 672 Rankine. Beta, one time the beta, it's literally, I can say, very easy question asked by JE. Beta, this is what they ask something like that. Beta. What's the temperature difference of this? What's the temperature difference of this beta? So easily you can find. That's what you can say easily find. Now, let us suppose beta try to understand the situation. Beta, you can take for the entire consideration. What's beta this length? This is what you can say L. L is what length between freezing point and beta what boiling point. L is what was against length between freezing point and which you can say this is what boiling point. Okay, let us suppose from anyone from both of you. There are three people from anyone from I can say all of you three can ask, sir, this is the fixed for L length. This is the reading fixed for L length. This reading also fixed for L length. This reading also fixed for this length. This reading also fixed for this length. Let us suppose, sir, I wanted to know what is reading of degrees Celsius scale at any value of x. Let us suppose, sir, this is x value from what you can say bottom to top. You can see beta bottom to this desired length x. So now tell me, what is the reading of degrees Celsius scale at a distance x? At a distance x. So now beta, now students, I'm going to same thing beta. Here also you can say x. Same thing, my dear, you can also apply. Sir, this is what remains x. This is what you can say remains x. This is what remains x here. Okay, this is beta, you can say remains x only, right? Okay, so beta basically you wish to find here. Beta we wish to find what is the bacha ji, I can say scale reading. So now bacha I'm going to give you bacha because you want to find what is the reading of degree Celsius at a distance x. So that now I'm going to give you the reading of any measuring scale. Beta, this is formula formula of region of any beta g, any measuring scale. Beta, what you can see, this is the formula beta, formula of region of any measuring scale, right, beta ji? Okay, so what's beta formula here? How can you think? Yes, beta. This x is what? Distance reading of, I can say, for Celsius scale. So you can write, my dear, this is scale reading. This is what, my dear? Scale reading. Upon beta is scale reading minus beta minus, my dear, minus freezing point. Upon which is the boiling point minus beta the freezing point, which is nothing but always you can write this is what constant. This is what, my dear, constant. Okay. Let us suppose you want to find what's the reading of Celsius scale, bacha. So, beta, you have to apply this formula to find reading of degree Celsius scale. So let us suppose, beta, here I'm writing reading of, bacha ji, reading of degree Celsius. This is degree Celsius scale. Now let's check. What's the scale reading? This is x bacha. We can write x. But what is the bacha party? Tell beta ji, formula of this here. So add x beta, x upon L bacha. This is remains constant. X upon L beta ratio. X upon L bacha party. What's the latest suppose? You don't know. So you can take that this is degree Celsius or C bacha. So you can say scale reading is what? C minus freezing point is what? 0 upon beta g. Boiling point is 100 minus c. Beta what you can say 100 minus beta it remains 0 here because what's the formula? So this is what you can write remains 0. Let's beta try to understand here. I can say another example. Yes, beta g. Let us suppose you wanted to find which region of degree Fahrenheit. You wanted to find which region of degree Fahrenheit. Yes, beta Fahrenheit here. For Fahrenheit, beta. Correct, beta. So this is what my dear, very good here. Degree Fahrenheit. So beta again you can write x upon L is equals to degree Fahrenheit minus beta z 32. It's the boiling point, freezing point. 32 upon beta z. This is 212 minus 32, which is nothing but here. You can say x by sorry, you can say beta degree Fahrenheit by 180. Degree Fahrenheit, right? What you can say, bacha? Degree Fahrenheit by what? You can say, bacha, 40, 180. Correct, yeah, very good. I'm very happy to see, bacha, your reply, bacha. Literally, beta. I'm very happy to see, bacha, buddy. So now, bacha, what's the next point here? Which we understand. Basically, bacha, conversion of scale. Beta, what you can say, bacha? Conversion of scale, bacha, buddy. Right? That is beta major point here. Or you can say relation between temperature of different scale. Let's say next point I wanted to discuss with anywhere which I can find beta for any scale. Beta here what you can say x upon L is what? This is k minus 273 upon which is 373.15 minus which is 273.15 bacha. So beta I can write beta like that. All I can say measuring scale of temperature. Now which I wanted to discuss that is next one, my dear. Relation between what student. This is the next point. Relation between temperature of different scale. Relation between beta temperature of different scale. Yes, beta. relation, what was that? Beta got bless you for reaction, my dear. Relation between temperature of different scale, right, Bacha ji? Okay, so Bacha ji, for this condition here, beta, what you can say, beta, I'm writing beta one by one. So this is what Bacha, degree Celsius. Uh, this is beta C minus 0 upon beta G 100 minus 0 upon Bacha ji 100 minus 0, which is equals to what Bacha? Tell me. Next beta G. This is degree Fahrenheit here. You can see this is F. The degree Fahrenheit was I could write here of beta F also. F minus 32 beta G. This is 180. Next beta G, what you can see? K minus 273 upon beta G. This is what you can say. K minus 273 upon beta G. 100 near. 373 minus 273, which is right. Okay. Next beta G, I can say. Beta, what is next one? Remove beta G. So this is what beta I can say. R minus 0 upon which is 80 minus 0. Beta on last, what is the last letter party? Rankine. So Rankine beta, I can also say beta this is RA. God bless you, my dear, for your reaction. Beta this is what RA beta party, right? Okay. So beta here I can write, my dear. This is beta G RA minus beta how much I have taken here? 470. Beta this is 470 upon what? 672 minus 470. Student 672 minus beta जी, okay, 470 minus beta जी 470. But I know beta somewhere, but student somewhere you will get, my dear. That is what R8 minus 492 also. Student somewhere you can also get what's happening. Same thing. I wanted to write here. There is no confusion at all. Beta RA minus student 492 upon beta G 672 minus beta G 492 minus beta G 492, right? So this is the fun beta which you can keep in your mind, beta. God bless you for your reaction. Student, God bless you for your reaction. Okay, so this is the point beta which you can keep in your mind. It literally beta highly important, my dear. Which is highly what which are important, my dear. Okay, now beta I'm going to give you beta one questions, just to beta for practice only. Just student questions based on I can say above concept. Student convert 32 degrees Celsius. Student convert 32 degree Celsius into Fahrenheit. Into which this is Fahrenheit. It got this for your reaction. Yes, beta. Do convert which is 32 degrees Celsius to beta Fahrenheit. Okay. 64. Okay. I got beta. Sagar, your answer. I got beta. I beta calculate here, then I can tell. Without calculation, I can't tell which party. Now, students have a look solution here. The students have a look. Okay. Okay. Beta solve completely which party. Students solve completely bacha, right? NS. So beta I'll use bacha this relation here. Beta I'll use bacha this relation here. So this is what you can say C by 100 is equals to beta F minus 32 upon beta is 180. Right. See beta how much mentioned here? That is 32. Beta what is mentioned by the party? This is 32. So 32 upon beta 100 is equals to beta f minus 32 by 180 beta. 25 is a 100 here and 29 the 80 beta. Just do multiply with the party. So 32 into 9 is equals to f minus 32 into 5 beta. So 9 to the 18 here and 9 3 the 27. 7 beta 18. 9 3 the 27. 28 beta. This is 288 is equals to beta. This is what you can say 5f minus f 160 beta. Come beside here. So 288 minus 160 beta. This is 5f. 0 86 beta 2. This is 120 beta. This is 5f here. Right. So a beta, how much I'll get here? Tell me beta about it. Uh, how much beta coming here? 288 minus 116 here. I wrote wrongly. This is 128. So f beta what you can write? 128 by 5. 5 to the beta ji. How much coming here? Tell bacha. How much coming bacha party? 5 to the 10. Right? 25 points. Okay. Okay. Who wants to the class? 12 class is timing. Okay. Beta woman, beta as usual bacha. Today class timing beta 10 o'clock. Today class timing bacha for 12 class bacha for 10 o'clock. 10 o'clock bacha. Correct beta. Correct NS. NS beta correct beta. NS correct bacha ji. Beta, you can what degree Fahrenheit beta. What we can see? This is what beta 25.6 degrees Celsius. Correct beta NS beta. Correct, correct. Sagar, you got delay for this question. You got delay for this question. Okay. Yes, beta. Now, bacha, have a look next question. Yes, beta. Have a look next question, bacha. Uh, what's the question, bacha? Party? It's a very common question here. Common reading, beta. Student question, bacha. It's a beta very common questions. Common reading on Celsius scale and Fahrenheit scale is. Or we can write here as example, find find out temperature, find out temperature at which magnitude in at which magnitude in degree Celsius and degree Fahrenheit is same. Answer which? Okay, sir, you did wrong. Why? What I did wrong? Okay, anyone? Answer you, beta. Beta, God bless you for your direction. Hmm. Answer me, beta. Okay, now I'm solving bacha body. Sir, before question. What? Answer correct, ne only, yaar. Correct only. What is change? Same. Tell. What is change? See? Tell beta. Sagar, tell beta. Where is wrong? Oh, Sagar correct ne yaar. NS correct ne yaar. This is plus basically yaar. Will come this side, then plus only. You correct Sagar beta. Yes. You correct beta, Sagar beta. Yes, beta. My bad. Apologize, beta. So this is beta f beta. What you can write? Beta, this is 8. Add beta simple here. So 8 bacha and 8 plus is beta. This is what you can say 14. 2 plus 1 3. And this is what 4. By beta what you can see 5 beta. So beta you can see here this is the is equals to beta Fahrenheit. Beta 5 8 is 40. Yes, beta. So you can see, bacha, as answer here, degree Fahrenheit, 5 8 is 40 and 5 9 is 45. and 5 is the 30 years. 89.6 degrees Celsius. You correct, beta, Sagar, beta. Then why you are replying very, very slow? Reply quickly, beta. Huh? This is correct answer, beta. And yes, you also responded same questions only, same thing. Beside it wrong. This is wrong, beta. Beta, Sagar, beta, God bless you for a correction here. Be careful, beta, during your calculation, my dear. Okay, beta, come to the point here. This one. Okay, my dear. NS. Beta, answer me, beta, this question. Find out temperature at which magnitude in degree Celsius and degree Fahrenheit is what remains same. Yes, Bachaji. Answer, beta. What's answer for this question? Oh, minus 40 degrees for this question. Okay, fine. Yes, beta. I'm going to solve, my dear. Then you can understand easily. Simple, beta. Just apply formula, beta. But this is what? C minus 0 upon beta G 100 is equals to F minus 32 by 180. Beta C and F beta, both you can take X only. So this is what, my dear? X minus 0 upon beta G 100 is equals to X minus 32 by beta G. This is what? 180. Beta 25 is the 100, beta 29 is the 180, beta. So this is what you can say. 9X is equals to 5X minus beta G 160, beta. This, yeah, 9 minus 5 beta 4 na, yeah. Beta 9 minus 5 4 na, yeah. So 4X is equals to minus 160. Correct, beta party. So X beta, what you can say? X is equals to minus 40 degrees Celsius. Correct, both of you, beta. Correct, beta. Correct, bacha. Both of you, bacha, party. Both of you, correct, bacha. Okay. Now, bacha, see, I can see here, there is a what? Beta, we have to discuss your graph, right? Graph, I can say for entire relation, bacha, party. First, beta, we can draw here, I can say temperature. Beta, what? What is the relation here? You can just think once. But let us suppose we don't know what's the temperature, bacha. So let's beta have a look about, I can say discussion. Bacha say this is what beta I can say temperature scale here. So beta I'll write this is beta I can say draw graph of beta God bless you for your reaction. Draw beta graph here. You can say bacha what beta say this is first beta I can say beta Fahrenheit degree Fahrenheit versus bacha this is what degree Celsius. Now bacha 30. So beta we will use here this result. So what bacha you can say temperature of Fahrenheit minus bacha ji 32 upon beta ji 180. Temperature of degree Celsius upon bacha what you can say 100. Simple beta I can use here. So beta this condition here. No beta somewhere idea somewhere they can also tell beta this is also beta known as what ice point. Students somewhere student they can say this is also what ice point, right, my dear? Okay, so beta what you can see T minus 32 beta 180. So just go through beta once relation here. Temperature versus this beta party. You can simply say beta this is on y-axis. Beta, this is what you can see y-axis. Beta, this is what you can see beta x-axis. So beta, just solve further beta party. You will get relation. Beta, this is what? Beta 25 is 100 and 29 is 80 beta. So you can say T final minus 32 into beta G 5 is equals to beta 9 times of TC. So you can see, bacha, this is 5 times of temperature final minus 160 is equals to 9 times of Tc. Beta, just yeah, I wanted to just beta just convert in the form of pi is equals to mx plus c. So you can say, my dear, 5 times of Tf is equals to 9 times of temperature degree Celsius plus beta is 160 divide by beta 5 only. So you can say temperature of panel means Fahrenheit beta is equals to 9 by 5 temperature beta is degree Celsius plus beta the 160. Now beta you can compare beta this result. Student, you can compare my dear this result from what picture? You can student you have to compare this result student y is equals to mx plus c. So beta what you can see says slope is positive, intercept is what? Positive. Intercept beta what you can say positive here. So bacha party what you can write bacha party finally here as a graph temperature beta we have something here plus slope c. So this is graph beta you can draw. This is the graph beta you can draw bacha party. Beta what is starting point beta from degree Fahrenheit. This is what beta you can take degree Fahrenheit beta. So God bless you for degree beta Celsius only. So this is a student you can see 32. This is what my dear 212 beta. And this is what dear you can say 100 degrees Celsius. So what's the delta T over here? Student, what's the delta T? So delta T nothing but you can say 100 degrees Celsius. Delta T nothing but delta T beta what is 100 degree Celsius. Sir, why did you not divide 160 by 5? 160 by 5? Hmm. Yes, you can take beta. Yes, beta. I have wrote correctly, bacha, party. Correct. And it's correct, bacha. Then beta 32 only coming, right? So beta, I have started graph beta from 32 only. NS beta, very good here. NS beta, what? You can say this is what I can say. But I have taken simple beta. But only beta I didn't write over here. I hope you got it. Got it, my dear? NS, reply me as no. Your doubt clear? Okay, fine. Fine, bacha. Now beta, have a beta next. Next beta, you have to draw bacha party. Next, I can say bacha. This is what my dear. Beta, I can just show Fahrenheit versus beta Celsius scale beta. Right, already we have drawn. Next beta, you can draw beta Celsius versus Fahrenheit. Next beta, you have to plot a graph. Beta, you have to plot a graph. Beta, this is degree Celsius versus beta G degree Fahrenheit. Degree Celsius beta what you can say versus beta party degree Fahrenheit. So this is what my dear degree Celsius beta or you can also say beta Celsius scale. And this is what my dear Fahrenheit scale. This is what my dear Fahrenheit. Beta this okay, but you can't able to say na. You can't send me. Okay, so beta this we go through beta. I'll use beta result as usual. So this is what temperature beta C minus 0 upon beta is 100 minus 0 is equals to beta temperature beta is Fahrenheit minus 32 upon which property you can say this is what 180. But now this time this is TC beta or I can say on y-axis. So beta just divide here 29 is a 180, 25 is a beta 100. So you can say TC by 5 is equals to temperature minus 32 upon 9 by property. So beta you can say like that. This is beta G TC is equals to 5 upon 9 times of TF minus beta 5 into 32 upon 9 beta party. Right. So beta for this condition here, what will you get beta party? Result here. Beta, what is the result will you get beta party? You can just compare beta party this result here from here. Student, you have to beta compare here this result with y is equals to this is mx plus c. You can see beta slope is positive but intercept is negative. So beta, what's the graph here? You can draw beta graph is what? This is the graph beta. Slope is positive beta and intercept is what? Negative. Intercept beta what we can see negative here. So this is graph beta. What you can see what this is scale. Beta I can write my dear. This is what beta see 32 degree Fahrenheit. Beta what you can see 32 degree Fahrenheit. And slope is whatever what you can say. Slope is equals to beta. This is a 5 by 9. This is what my dear can say. This is nothing but it's a slope. This is nothing but it's a beta slope. Last which I got just do beta one more. Celsius versus Kelvin bacha. Student next. You have to draw bacha. This is Celsius versus my dear. This is what Kelvin. What is the party? Celsius versus Kelvin. Okay. Beta, can you draw the graph, beta? God bless you, beta, for your reaction. Student, can you draw the graph? Student, can you draw the graph? Just write, beta, just write. I can see in chat box, beta, that in which quadrant your graph is lying. First quadrant, like this is what you can see. What's a graph in what a fourth quadrant. So light it, bacha, just respond me, bacha, party. In which quadrant your graph is lying? Like first quadrant, second quadrant, third quadrant, fourth quadrant, fifth quadrant, bacha. Okay, so this is what. Now what I'm solving here. Temperature, this is degree Celsius scale. What I wrote, this is temperature degree Celsius versus Kelvin scale. Okay, so bacha, this is a graph, bacha, degree Celsius T minus 0 upon beta is 100, but a temperature of Kelvin minus beta is this is 273.15 upon bacha. Tell this is you can say 100 only. 100 was two because 373.15 minus 273.15 beta, which is equals to 100 only. So now students, you can see here. So this is cancel. This is cancel. So simply can I write which about E temperature C is equals to temperature K minus 273.15. So you can see, so this is the graph similar like this. You can compare Navita. Y is equals to mx plus c. Intercept is negative, bacha. Slope is positive. Student, intercept is negative and slope is what, my dear? Positive here. So this is what? Beta degree Celsius and Kelvin, bacha body. So you can draw beta graph as usual same. Student, you have to draw beta graph as usual same. Right? Okay. Uh, I hope. Good, oh, good, Inespita. Oh, Sagar, you also very good, very good, my dear. Now, Beta, I can say after this year, Beta Sagar, can you draw Beta once more? Kelvin versus degree Celsius. Beta, just answer me like this, Beta, party. Kelvin versus Beta, just draw Beta. It's an assignment. It's Beta, I can say your homework. Beta, this example is a homework. Beta, you have to draw. This is Kelvin versus degree Celsius. Beta, if you Beta assignment, send me here, Beta. Beta ji, your assignment, beta, you have to send me here. Hmm. Beta assignment, you can beta send me on WhatsApp. Your assignment with party. Beta, if you solve it, then beta you can send your which I'll give the assignment today class. All assignment beta, you can send me here in PDF format. All assignment student you have to send in PDF format here only, bacha. Okay. I hope you have taken a screenshot. Now bacha, have a look here next. Beta ji, have a look bacha party next year. So this is done bacha party. I can see beta after this year. What's the point we have to discuss? Beta in thermometry, bacha, in thermometry, no, there is what? Linear variation in some physical properties of a substance with the change of temperature is the what? Basic principle of thermometry. These properties are defined as the thermometric properties of the substances, like what I can say length of a liquid in capillary, pressure of a gas at a constant volume, volume of gas at a constant volume, my dear, resistance of a given platinum wire. These all things, beta. These all things which are discussion, which is what I can say considering under what bacha party thermometry. What, my dear? Thermometry. Okay, 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 beta. I hope you answer Ines beta for this question. I hope beta answer beta for this question. Maybe. Yes, and Ines beta, your answer correct, bacha party. Ines beta, your answer beta correct beta for this question. In first quadrant only, my dear. In first quadrant only, my dear. Okay. So beta, I can say beta in now beta in old thermometry, freezing point is zero and steam point is what beta? Boiling point. Beta, in the paper hall. Beta in paper hall, my dear, I wanted to tell something regarding beta numerical. Beta in the paper hall, they will write ice point. So your mind will call. Ice point they will say for degree Celsius. So your mind think, oh, ice point is 0 degree Celsius. But they will also mention here. What, my dear? Steam point for degrees Celsius scale. So what you can say? 100 degrees Celsius. What you can say, Bacha Party? 100 degrees Celsius. Okay, very good. Now, Bacha Party, I can say, Bacha Party, for this condition here. Already I give the relation. Already, Bacha Party, I give the relation. Right. So let us suppose, beta, you can say we have to discuss Prajapati. What I can say, some common types of thermometers, right? That is beta major point for I can say major discussion point for this class. Okay. So bacha, what's the beta? I'll start calorimetry. Bacha ji, some common types of thermometers. Beta, what's the next reading? My dear, this is some common types of thermometers. Thermometers. Yes, beta. Some common types of beta thermometers, right? So I can see, but basically, we have a many variety of thermometers. So I'll discuss one by one. So beta, first I want you to tell you which I'll discuss over here. So this is beta, you can see first one, which is liquid, or you can say beta mercury beta thermometers, right? Next beta, you can say gas thermometer. Next is what beta? You can say gas thermometer. I'll write once here. This is thermometers. This is what, my dear? Thermometers. Okay. Beta is the third one. Beta which I'll discuss. Resistance thermometer. What, my dear? Resistance thermometer. Okay. And beta, fourth one. This is vapor pressure thermometer. In fact, beta, in gas thermometer, yeah, beta ji, in gas thermometer, I'll discuss beta. There are two different kinds of thermometer in gas beta ji. One is what? Constant pressure gas thermometer and constant volume beta party. Beta in gas, I'll discuss beta. There are two category. This is what? Constant volume. And next beta ji, this is constant pressure. This is what beta? Constant pressure, yeah. Beta resistance gas thermometer beta, then I can say vapor pressure thermometer. Vapor vapor beta is pressure thermometer. Vapor pressure beta, this is thermometer. Everywhere thermometers, yeah. Okay, next beta is last one, in second last beta, this is fifth one, thermoelectric beta thermometer. This is thermoelectric thermometer is the electric thermoelectric thermometer. Thermometers. But this is last one, bacha, which is radiation thermometer. Or you can say better somewhere better. You can say pyrometers. Both are remain same, bacha. Either you can say, my dear, radiation, radiation thermometer, radiation beta, thermometer, or students, you can say pyrometer. This is pyrometers. This is what, my dear, pyrometers, right? So this is basically point which beta I can keep in your mind. Now, beta, I'll discuss here. I'll discuss with Chapati. Sir, can you give 3 or 4 questions on fluid statics at last? Yes, yes, I'll give. I'll give beta. I'll give beta. I'll give one yes, beta. 100% beta. Just remind me, beta. Beta, I can say beta in last beta. Just remind me, beta. I'll give you beta. Definitely. Sir, will you and yes, 6 o'clock. 6 o'clock. Yes, time beta. 6 o'clock. Remaining beta, I'll continue tomorrow. Don't worry. Remaining bacha, time only time bacha. 4 to 6 means 4 to 6 only bacha. Okay. Now beta, I wanted to discuss beta one by one. All time beta kinds of what? Thermometers. So first beta, I wanted to discuss, my dear. This is beta is liquid thermometer. This is what, my dear? Liquid thermometer. Yes, beta. Liquid thermometers. Yes, beta. So what is this here? In liquid thermometers, mercury is preferred over what beta I can say over other liquids as its expansion is large and uniform and it has a high thermal conductivity and low specific heat. Yes, beta. That is the point which I got. Why we are using liquid thermometers, bacha? Because bacha, expansion is large and uniform, right? And it has a high thermal conductivity. Beta, they can ask, bacha, what is the advantage why we are using liquid thermometers as a theory question? Beta, they can frame why we are using the student, because high thermal conductivity and low specific heat. It is based on the what? It is based on thermal expansion of liquids such as mercury, alcohol, etc. But what's a liquid thermometer, students? It is based on student. It is based on. Beta, God bless you for your reaction, bacha. It is based on the thermal based on the thermal expansion of liquid, beta. Thermal expansion of liquid such as mercury, alcohol, etc. This is what, my dear, etc. Okay, fine. Then let's about here, yeah. What is the range? No, bacha. Already they can ask bacha as a theory questions, right? What is the range of it? I can say liquid thermometer. So read bacha the somewhere beta they will mention -30 to 357 degrees Celsius. Somewhere beta they will also give you -38 degrees Celsius to you can say 357 degrees Celsius. So I'm writing both. Beta, I'm writing both here. This is 38 point beta 8 degrees Celsius. It's a range. To bacha, This is 357 degrees Celsius. It's a what? You can say range. It's a what, my dear? Range of liquid thermometers. Beta, what you can say? Liquid thermometers. Then, bacha, you can say upper limit of range of mercury thermometers can be raised up to what, beta? 500 degrees Celsius or beta 550. Maximum range, bacha. You can say upper limit of range because you know everyone here. Boiling point and freezing point. Boiling point and freezing point, bacha. Because now what we are learning, thermometry, bacha. Right. So, beta, for this condition, you can keep in your mind upper limit of range of mercury thermometer can be raised up to 500 degrees Celsius or 550 degrees Celsius by filling nitrogen in space over mercury under high pressure. Beta, keep in your mind. Beta, one time, beta, this question asked by what? I can say, beta, JE beta, right? Or somewhere beta in any competitive examination in 1992. 1992 beta. What's question they ask was about the upper limit. I'll write beta entire statement here so that you can keep in your mind. Upper limit, student, upper limit of upper limit of range of mercury thermometer mercury beta G thermometers thermometer only not yes thermometer can be raised students can be raised up to beta G 550 degrees Celsius somewhere beta they can also give you 500 degrees Celsius but I can take both in consideration right by filling student by filling nitrogen in space by filling with a nitrogen in space nitrogen in space over over mercury right bacha under high pressure what my dear under bacha ji high pressure under bacha ji high pressure. Yes, beta. So this is a point, beta, which you can keep in your mind, beta, party, right? It's beta highly required. Next, beta, the points about theory point, beta. I hope you written a beta, or you can write beta. Once again, yeah, I'm just showing you beta all the points of the theory. Theory point, beta, I can say about liquid thermometers, my dear. I hope you have written. Yes, beta, ji. Beta, God bless you for your my dear. Okay, the next one, what you can say? Mercury thermometer with cylindrical bulbs are more sensitive than those with what spherical bulbs, right, beta? Cylindrical bulbs, beta, what are more sensitive than what those with spherical bulbs, right, beta? Okay, beta, if alcohol is used instead of mercury, listen beta carefully. If alcohol is used instead of what? Mercury, then range of temperature measurement becomes what? Let us suppose, beta, I can just say, beta, as a theory point, beta, let us suppose you are beta replacing, which means you are just replacing, beta, you can say mercury to what, beta? Mercury to tell me alcohol. So, what's the range of temperature? What's the range of temperature? Here, what's the range of temperature? Minus 38 degrees Celsius to beta what we can say up to 357 degrees Celsius, right? But yeah, if this replace with mercury to alcohol, so what's the measuring temperature of chapati? This is you can say 80 degree 80 degrees Celsius to बच्चा जी 350 degrees Celsius. 80 degrees Celsius to what bacha 350 degree Celsius. Now but that is the last point bacha ji. What is the formula? What is the formula to find you can say bacha temperature. So beta this is what temperature finding beta formula which is last one for I can say liquid. Yes beta what's the formula here? So this is beta I can see temperature finding formula my dear. T is equals to this is what beta I can say length L beta. This is beta LT. You can say reading temperature minus beta. This is beta L naught. Upon beta, this is what you can say beta. Same thing here. But I can see scale reading minus freezing point upon boiling point minus beta the freezing point beta. So you can say beta this we are discussing about degree Celsius scale. So we can say beta this is what L because no what is the boiling point for degree Celsius? That is 100 beta minus which you can say this is L0 and temperature you will get with a multiply by 100 in what degrees Celsius. So with that, this is the formula which you can keep in mind for what mercury thermometer. For what my dear mercury thermometer. Okay. But after this, which I wanted to discuss that is a gas thermometer. So I wanted to discuss this is gas, which is a gas thermometer. Meter what gas thermometers, right? So these are more sensitive and what accurate than liquid bit of what you can say liquid thermometers. It has a gas thermometer is what which beta I'll teach you I can say in the chapter of beta current electricity because beta voltmeter is a device which also used to measure what beta potential difference. Beta there is one more instrument here. What's the name of that instrument? Basically, which I can say potentiometer. So potentiometer also with I can say used to measure potential difference I can say or drop in the circuit. But why we are not using much? Why we are not using much? Because the potentiometer has a lengthy setup picture. Right. In fact, I can say reading accurate is more. So same thing, bacha. This as a comparison, you can remember, beta. I can say gas thermometer. It's what measuring more accurate temperature of material or body and whatever with respect to you can see better what this is what liquid or mercury thermometer. So these are the more sensitive and accurate than liquid thermometers because expansion of gases is more beta expansion of gas beta why I'm calling beta because expansion of gas is more than that of liquid beta the thermometers using as you can see beta gas thermoelectric substances are called and what gas thermometers. So beta as I said beta gas thermometers I'll discuss into conditions. Different gas thermometer which I'll discuss into condition. One is what beta this is constant volume or constant beta pressure as already I said bacha constant pressure gas thermometer beta and this is constant volume gas beta the thermometer constant volume bacha what you can say gas thermometer bacha so this is beta first I wanted to discuss my dear this is constant pressure beta ji sir, which thermometer is most accurate? Beta, I can say, beta, we have just beta end of the discussion. Beta, I can say, if we have a two, beta, I'll tell in last after discussion which one is more accurate. But now just I finish with a liquid and gas. So liquid is less with respect to gas thermometer because expansion is more. What gas, bacha, party, right? So beta first I'll finish with chapati, then I'll tell in detail which one is more and which one is more useful for us. constant pressure gas thermometer. What, my dear? Constant pressure gas thermometer. Yeah. So, beta, what is the principle, beta, which you can use? Beta, pressure is what? Beta, just use your ideal gas equation. So, Bachaji here, beta, what is ideal gas equation? PV is equals to nRT. Beta, what's the constant pressure? Bacha, you can say, sir, pressure is constant. If pressure is constant, so you can say, bacha, volume is what? Directly proportional to temperature. Volume is what, bacha, party? Directly proportional to temperature. So, what's the formula, bacha? Already I gave bacha formula over here. Same beta you can apply over here also. Same formula beta I can apply here also, bacha, to getting temperature, bacha. So what was the part you can say? This is what volume means what I can say. This T means what implies skill reading of volume. Now let's say party. Okay, the minus beta party, what you can say? This is beta volume. Beta you can say at beta this is freezing point. Upon beta party, volume at boiling point minus beta party, volume at freezing point. Student, don't forget to multiply by what? 100 degrees Celsius. 100 beta what you can say degree Celsius, right? Beta party. Okay. Next beta party, just move next here. Beta, this is constant pressure beta. Have look beta next. So this is what, my dear? Constant volume. Constant volume beta gas. Beta the constant volume gas thermometer. Thermo Yes, beta. Constant volume beta gas thermometer, right? So beta for this condition, again beta, I'm going to use ideal gas equation, my dear. So this is what PV is equals to nRT. Beta here you can say volume is equals to constant. So beta you can write over here pressure directly proportional to temperature. So beta just be remember formula, my dear, how to find temperature of this scale or this thermometer bacha. So this is what temperature is equals to, again you can say reading of pressure, or you can say skill reading of pressure. Beta this is T, beta you can write small t minus bacha party. This is what you can say at a freezing point. Upon bacha party, this is a pressure at beta the boiling point minus beta what pressure at bacha basically freezing point bacha. So this is the formula beta which you can keep in your mind. Right, Bachaji? Okay. So, beta, there is something here which you can use, but no, rarely they can ask range of temperature. Leave it, Bacha Party. Leave it, Bacha Party. Okay. Next, Bacha, what is next here? This is done. This is done. Resistance thermometer. Beta, what is next, Bachaji? This is student resistance. Resistance, Betaji. This is thermometer. The what resistance beta thermometer. Okay, usually beta platinum is used in resistance thermometer. What is today? What substances and material to use to just produce this thermometer was party? This is what you can see. Maybe they can ask what's the nature of material and what's the name of material which they are using and they use to produce resistance thermometer. Which so you can keep in mind. This is platinum. This is what, my dear, you can say this is nothing but it's a platinum thermometer. Okay, is used in what resistance thermometer due to high melting point. Why, bacha, why they are using it? Because platinum has this major point, but this can keep in your mind here. I'm not telling too much. High melting point. High, which has a melting point. High beta what you can say melting point, and large beta large value of what temperature coefficient of resistance. Temperature coefficient of resistance. Now beta I'm going to give a party one relation here. This is a beta part of current electricity which I'll prove later, right? But now bacha, this is the result which you can keep in your mind. Resistance final which is equals to what, my dear? This is resistance initial 1 plus alpha delta t. But I know this thing here, alt is very soon, bacha, linear expansion of matter. So, beta, from there you can compare, bacha. This is, you can see, let us suppose, you can understand. as an example, resistance of the wire or any thermometer, because here what we are discussing about thermometer. So you can say that is 25 ohm or 1000 ohm and whatever. So at 25 degrees Celsius, this is the resistance of this thermometer. You have to find resistance of temperature at 100 degrees Celsius, like that. They can ask questions. So simply, but I can apply the formula. Student, you can simply apply the formula to get answer of these questions. Now, bacha, what's the formula here? Like this. So formula beta, you can just use simply temperature is equals to resistance beta. Again, you can see scale reading minus bacha bati freezing point upon beta. You can see this is beta boiling point minus bacha the freezing point, right? So temperature bacha simply for this case, you can find which quantity easily. Temperature range which are for platinum resistance here. Yes, this point they can also tell. Range, you can just keep your mind. What's the range here? Exactly, yes. This is students minus 200 degrees Celsius to beta. This is 1200 degrees Celsius. Yes, this is the range which party for what you can see. This kind of beta thermometer. For germanium resistance, beta thermometer is what you can say 40 Kelvin. They will not ask. Leave it with that. Okay, beta next vapor pressure thermometer. What is the next year? Sagar, image. What's the next about it? This is yes, vapor pressure. We have remaining three only. And I'm also going to finish 30 minutes only, bacha. So this is beta. What is next, my dear? What is next, my dear? So this is beta. I can say vapor vapor pressure vapor pressure beta thermometer beta what you can say vapor pressure thermometer beta. Okay, so beta ji, for this condition, what is the point which you can keep in mind? These are used to what? What's the beta application and how the things we can just take a basic idea about vapor pressure thermometers. These are used to measure very low temperature. What is student? These are used to measure very low temperature, and this depends on fact that saturated vapor pressure of a liquid depends on temperature by certain relation. Right, bacha bati. So, beta, there is a one relation, bacha, which you can keep in your mind. So, this is beta g log of P. It's a pressure is equals to beta A and B beta. Both are constant, bacha bati. And this is what T is a temperature plus bacha g. This is C by T. No, how it came? No need to think. Just beta go through formula. Go through formula beta. A, B, C all are constant beta party and temperature in Kelvin. No, it's a range beta. Range remember of all. So range beta maybe students you can say range you can take in consideration. This is 0.71 Kelvin to beta 120 Kelvin. 0.71 Kelvin to beta what we can say beta 120 Kelvin. Principle is what beta? What's the principle on which you can say vapor pressure thermometers is working beta? So saturated vapor pressure of a liquid depends only on temperature. Student, I'm repeating here. Just beta note down this point beta in notes. My dear, note down this point beta in notes. Sir, can you do question? Oh yes. Beta 5 minutes bacha. I'll beta complete na this one. Then beta I'll start with the fluid. Right? And yes, beta. I hope you got my point. Beta saturated vapor pressure of a liquid depends only on what temperature. Beta what only on temperature. Okay. Now bacha party. This is I can say beta fifth one maybe. Beta this is fifth bacha party. Thermoelectric thermometers. Beta this says thermo electric thermometer thermoelectric thermometers Yes, beta. Thermoelectric, beta, what you can say thermometers, beta. Okay, beta, what is the principle on which I can say this thermometers is working, beta, party? These are based on Seebeck effect. You can say that what's the Seebeck effect? That is when these similar metals are joined to form a closed circuit. What, beta? What's the beta Seebeck effect? When dissimilar, not like. It is unlike. Unlike metals are joined to form a what? It has a closed circuit called thermocouple, and a difference of temperature is maintained between their junction. Then thermo EMF is developed, and the variations of thermo EMF with temperature of hot junction is that there is a mathematical beta. These things beta done in the laboratory and prove the result beta as there. So now students, I'm giving you beta same result. So what is beta? You can say E, which is equals to AT AT plus beta BT square. E is equals to beta. You can write this is AT plus beta BT square. Right. What is the range beta? Party range beta. Keep in your mind, students. What is the range? Range beta. This is minus 250 degrees Celsius, minus 250 degrees Celsius. To beta, you can say this is 3000 degrees Celsius. Right. The last one here. What is last beta party? This is radiation therapy. Yes, beta. Beta, they already asked questions here. So student they can ask radiation. This is what, my dear? Thermometers. Simply beta, or they can also say are pyrometers, right? So these are used to measure what? High temperature. Yes. Beta, what's the basic application, bacha? You can say for radiation thermometer to measure what? What bacha party? To measure, to measure what, student? This is high temperature. This is equal to meter with a high temperature, like temperature of sun and stars. If you want to measure sun and stars, what's the temperature with us? So you can use what? Radiation thermometers. These are based on Stephen's law. Beta, what you can see, these are based on Stephen's law. The device is, Stephen's law, beta, again, part of beta radiation. Beta, what is student? Stephen's law is a part of what, my dear? Radiation. The device is what exposed to sun radiation and its intensity is reset. Now, intensity of radiation is directly proportional to fourth power of absolute temperature of hot body, means sun body, bacha. So, beta, I know this thing, beta, again, I'll prove, bacha, party in the chapter of what, my dear? You can say heat, right? So, beta, what is there? You can write over there. This is beta, you can say I, which is equals to sigma E into beta T to the power 4. But what's the party? Sigma E to the power what's the party? 4. Where you can ask, sir, what is sigma? Sigma is beta, I can say this is Stephen's constant. And E is what, my dear? Emissivity. E is what, my dear? Emissivity. Emissivity beta. Now, what's the range? What's a range, my dear? So range which I can write, that is maximum range which I party for this kinds of thermometers. 800 degrees Celsius to beta G 6000 degrees Celsius. Beta G 800 degrees Celsius बच्चा to what you can say, my dear? 6000 degree Celsius. So what's the question beta I can say asked by like say Sagar Maharaj, sir, which one is more easy and which one is more perfect? Sir, is a thermoelectric thermometer used to check heat of electric current wires. Beta, you can say these are used to measure high temperatures like temperature of sun and stars. These are based on Stephen's law. So, beta, you can say advantage and beta, you can say property and where it is used. Only beta thermometer possible for very high thermometers. Beta, this kind of beta temperature, this kind of beta thermometers only you can use beta if you want to measure very high temperature, right, bacha party? So I can say beta which one is more yet. So now bachas, I'm telling you a little advantage. Then you can beta just tell beta Sagar Maharaj which one is more accurate. Beta listen carefully here. Beta I can say advantage of first bacha. I can say liquid thermometer. That is what bacha party quick and easy to use, right? Easily beta portable, that is beta. Next, you can say beta very accurate for what? Constant volume gas thermometer beta. Beta very accurate, very sensitive, wide range, and easily reproducible. At beta next, you can say beta constant pressure gas thermometer, or you can say beta platinum resistance, accurate and wide range. Beta, you can say thermocouple. That is beta what you can say, or beta you can say thermoelectric. This is what, my dear, fast response because of low heat capacity. Wide range can be employed. So, based on this, beta, just tell beta which one is more accurate. Which temperature is more accurate? Tell what's about it. Beta, I can see platinum thermometer. Beta जी platinum resistance बच्चा waste thermometers for small CD temperature difference. Beta we can also use thermocouple waste thermometer for varying temperature measurement. Right. So beta this is all about I can say बच्चा today class time is bonded बच्चा party. Remaining beta syllabus I'll beta complete. Calorimetry I have basically right. Calorimetry beta which I have to discuss. So student tomorrow timing I'm telling बच्चा tomorrow timing beta resistance yes beta Sagar Maharaj tomorrow timing beta NS that is beta 7 to 9. Tomorrow beta I'll just discuss little theory. Tomorrow I'll do beta numerical. Today class beta I'll discuss majorly theory only. Sir, fluid static questions. Yes beta I'm giving you my idea. Yes beta I'm giving you my idea. Fluid static questions. I can say something is available. Okay. Yes beta fluid static. Hmm. Yes, beta. For fluid static beta party, I can say this question beta we remember, right? Bacha na in the classroom where we did, there is a container beta, there is a ball, you beta drop from some height, beta they can ask two questions. Beta first they can ask once this ball completely under the water, so how much distance traveled? So beta first they can ask beta the distance. Next beta they can ask here time to time you have find time to I can see ball completely what you can see goes to what bottom of the container and again come back on I can say surface of water. So what's the timing? This is what you can see 2t. So student they can ask beta time also. This is the first questions. Next beta ji I can say beta ji for thermometer yaar. Bachcha ji, yes, I'm remembering. Beta, there is no if this questions here from your worksheet only beta. We have to find bachcha party. Let us suppose this question beta they can ask here 100% student. This is students you can see this is ice cube, right? Student there are two liquids. There are two liquids, right beta? Okay. So you can see bachcha this is water. This is water. This is water beta, and now you can say this is some different liquid, right? So beta, they can ask, what is the if ice completely melts, beta ice completely melts, then beta they can ask, what's the beta you can say increment and decrement in the level of, you can say bacha, this is what bacha ji you can write beta ji H1, you can write bacha ji. This is what S2. So beta, you have to comment once ice will melt, then you have to comment on level of H1 and S2. Now beta, this is questions number third beta. Let us suppose student this is a fluid statics question beta. This I'm telling you. You can say beta, this is container. My dear, container completely filled with beta liquid, right? Okay, so beta, this is, you can see there is ice cube which is floating on the surface of water. Beta, you have to comment on what if ice completely melt. So what is the level of water? Comment on level of water, Beta. Okay. Now, beta, this is next question, beta. You can think like that. This is student fluid static. This is student, you can say fluid remains at rest only. Now, beta, you can see there is what? Wooden block. There is what? Wooden block. Right, beta. Now, I'm placing a coin. Above the block, beta, I'm placing a coin. Above the block, beta, I'm placing a coin. Right. Then, beta, if coin falls into the water, then comment on. Then, beta, Z, comment on, comment on, beta, you can say level of water. Comment on, beta, level of water. Right, beta, this is the questions. Because you asked four questions, beta, so I gave you five questions. I gave beta four questions. Now, beta, this is last question, sir. Beta, I wanted to do beta in here only, beta. Beta, God bless you for your reaction. Ines beta, Sagar beta, if you're literally liking beta entire session beta, just show reaction beta, like the video, share with your friends beta, so that maximum student can get benefit of that. Okay. So beta, you can take a cancer setup like this. Yes, beta. Beta, you can take both have the same mass. Beta, you can see both have the same beta. There, I can say spherical body beta, mass remains m, mass remains m. Beta, God bless you for reaction idea. This theta beta, you can take beta. This is what 30 degree. Beta, you have to find student. You have to find student. You have to find acceleration. You have to find beta what acceleration, right? So these are the five questions which are definitely will get these five questions which are as it is. Student definitely beta you will get here this question as there is no doubt at all. There is no doubt at all, right? Beta? Yes, beta. Now. Yes, beta. Time over, beta party. So all the best, beta, for tomorrow test. Now, student, I'm going to stop live session of 11th class thermometry, beta.